Okay, V4 now. Oh, my pen. Right. Tacken. Oh. Help. I can't reach it. Thank you. Can you unplug your whatever you're charging and oh, actually no, it's okay. It's okay. Right, let's have a look here. B4. What have we got in part A? Show that there's a root. X cubed minus 15. Right, 2.4 cubed minus 15. So f of 2.4 is equal to minus 147 over 125. And f of 2.5 is equal to 5 over 8. Sign change. That implies there's a root between minus 147 over 125 and 5 over 8. Part 2, Newton-Raphson. Use Newton-Raphson method to find the root. So Newton, how many times? Only once. So x2 equals x1 minus fx1 over f derivative x1. So that means x2 will equal 2.45 minus 2.45 cubed minus 15. And the derivative, what's the derivative? It's 3x squared. 3x squared. So what do we get here? .47. Right. 3. Why does e to the 5x have an inverse? Well, technically it doesn't have an inverse unless you say that the codomain is the same as the range, which is all positive real numbers. But I think what he really cares about here is for you to say that it's 1-to-1. So this function here, gx, is 1-to-1. Therefore, it has an inverse. Although that's not fully true, but it's good enough for him, so whatever. Now, he says explain why it has an inverse. Well, to have an inverse, you need two things. Number one, you need to be 1-to-1. And number two, you need to be onto. I know, and I'm saying you have to have two things to have an inverse. You need to be 1-to-1 and you need to be onto. So, I actually think that it doesn't have an inverse because it's not onto. But it's 1-to-1.
They said find the expression.
Yeah, but what did he say is the reason for why it has an inverse?
Function has 1-to-1.
Did he say anything about being onto?
No.
Let me see.
It's just 3 marks.
No, I know, but my point is, it needs to be 1-to-1 and onto. So it's actually not technically, it doesn't have an inverse. Now this function, gx equals e power 5x plus 1, where you can use any real number and your answer will be a positive real number. non-zero. This is invertible, so I think this is what he meant. Anyways, we need to show it's one-to-one, or does he just say explain why? He doesn't care to prove that it's one-to-one? Fine. Fine. So let's get the inverse here. So we solve for x. What am I doing? How do I cancel the e? Log. So I get log y minus 1 over 5 equals x. So the inverse function is log y minus 1. F G 1. So what's G? G was the E function. Oh yeah, sorry. Thank you. F G. G is e power 5x plus 1. X is 1, so it'll be e power 6. And what's f? X cubed minus 15. So this would be 18 minus 15. Is that the answer?
Should give you exact answer in exact form.
And what's his answer?
In exact form. Using
Great. Part B.
which would be
Sine 15 equals sine 60 minus 45, which is sine A cos B minus sine B cos A, which is root 3 over 2, 1 over root 2, minus 1 over root 2, cos 60, 1 over 2, root 3 minus 1 over 2 root 2. Does he leave the answer like this? Probably.
yes.
Okay.
I put
Part 2.
express.
So, cos 2 theta equals cos squared theta minus sine squared theta. But what does cos squared equal? 1 minus sine squared. And you already have a sine squared here. So it's 1 minus 2 sine squared. So that's cos 2 theta. So cos 2 theta, 1 minus cos 2 theta over 2 is sine squared theta. So your integration of sine squared theta, d theta, can be changed into the integration of a half minus a half cos 2 theta d theta, which will equal a half theta minus a quarter sine 2 theta, and the limits are 0 and pi over 2. So if you put in pi over 2, you'll get pi over 4. Sine pi is 0, isn't it? And then if I put in 0, I get 0. Is the answer pi over 4? Great. 3. Show that tan squared theta over sec theta equals that thing they have there. I think I'll start on the right. Sec theta minus cos theta equals 1 over sine theta minus cos theta over 1, which equals 1. Sec is 1 over, no, sec is 1 over cos.
Yes.
Which is 1 minus cos squared theta over cos theta. I'll divide everything by something.
Sine.
1 is sine squared theta. Sorry, 1 minus cos squared theta is sine squared theta. And then I need a tan on the top, so I'll divide the top by cos squared, and I'll divide the bottom by cos squared. So on the top I'll get tan squared theta, and on the bottom I'll get 1 over cos theta. 1 over cos theta is sec theta, so tan squared theta over sec theta. Ooh. Can I go on to B5 now?